Well, thank you for having me here today. My name is Pascal Paschos. I'm the OSG Area Coordinator for Collaboration Support. And the Area Coordinator is a kind of an old term, but suffice to say is that I'm doing most of the project coordination in the way that the OSG basically handles or responds or interfaces with the collaborations on the fabric of services. The Mandatory Osg Consortium intro slide, it's a consortium dedicated to the advancement of all open science via the practice of distributed high-throughput computing, the advancement of its state-of-the-art. It's covered by an OSG council. We have a bunch of bylaws, executive director to coordinate a program of work. And in a nutshell, the OSG is a collaboration between CI, software, science professionals that provides the following items there. Okay, thanks. So we got training and consultation, service provisioning, compute and storage and data infrastructure, and a lot of our services is in the facilitation in the delivery of the data products that are very mission critical to some specific scientific investigations. So we're going to start by categorizing the participation of the people on OSG into the following four categories. We got to have individual researchers in small groups. We got to have campus research support organizations. And where collaboration support comes in is in the multi-institutional science teams. We call them mid-size collaborations. And there is a technical term how we decide what size a collaboration is, but probably not in the context of this talk here. But also we have a very large-scale projects. And the large-scale projects, examples are like US Atlas, CMS, LIGO, and IceCube. But in regards to these categories of participation, it's important to find out how we interface with those collaborations and those researchers. So when we refer to multi-institutional science teams, we refer to collaborations between a very large number of US campuses and institutions, and an important component is that these partnerships have international components like institutions or sites, campuses, and so on. Oops. All right, good. So how is the service requirements and expectations per category? When we're talking about individual research groups, we typically talk about the open science pool. This is a commodity research where people are doing their computation, and open science storage that are shared by all researchers. And they typically use the OSG Data Federation, which delivers data in close proximity to compute resources. Where the collaboration projects or engagement starts to differ is when we are having those collaborations start contributing dedicated resources. And these dedicated resources will form computing pools that they control. And there is a lot of complications that are coming out of that. Some people will actually, some collaborations may have access restrictions to their data. They contribute their own infrastructure in the data federation, and may include integration of storage at major international facilities. And so the challenge for us here is how do we coordinate an engagement that has all these different points for a particular collaboration. So in the nutshell, the takeaway from the previous slide is that collaborations do require a richer set of services than individual researchers. And that's why there is collaboration support as a distinct group within OSG. So some of the support engagements that we have at present. So when we're talking about individual research or campus group projects, these are mainly supported out of the OSG research facilitation team. But for collaboration projects, we are actually having this two different slightly categories. We have collaborations where they have some minimal or no staff or support teams to be able to integrate with OSG and their infrastructure and their workflows. In this case, the OSG provides such support that will promote the growth, self-reliance, and confidence. But of course, there are collaborations. As the scale increases, the collaborations provide and provision time for building support teams. And in that case, instead of simply supporting them, we are partnering with them in order to facilitate how we deal with their issues that they will inevitably emerge. How do we support their software and data products? And how we actually put in place the processes that will allow their infrastructure to grow without too much issues. So the collaboration support on OSG is organized in a way that facilitates the following delivery of services, from onboarding to computer and storage, scientific workflows, user and site support. And we spend some time also providing dashboards and monitoring tools for the benefit of the collaborations to be able to get a bird's eye view of what's going on with their deployed infrastructure. And we are engaged with ticketing systems, both internal and participating ticketing systems of the collaborations themselves. And we also contribute to technical publications. We provide contributions to the PATH NSF reports. And at present, that group of OSG supports about 13 collaborations, which includes the two large-scale ones, LIGO and IceCube. And additional collaborations are supported via our engagement with Fermilab, typically the Fermilab-based experiments there. Some examples of the collaboration support activities, they are listed here. I'm just going to highlight a couple of items here that we definitely spend a lot of time integrating collaboration support resources with into OSG and compute and data federations, help them deploy their own caching infrastructure. We do support the frontier shaping effort in the high energy physics community through the SNOMAS effort here. We operate and compute data and compute infrastructure. But then take away from all these engagements, which is just an example here, is that this whole process, especially with the operational part, is this can be quite complex when we're dealing especially in facilities that support multiple collaborations. So in that respect, I had prepared an animation that is in coordination with JLab. It was not for this talk, but it was something else that they would like to actually have to see. So I'm sharing with you here to basically highlight this complexity. So here's JLab experiments out of OSG. So in the bottom part here, you see those 4 collaborations that basically primarily work out of JLab. When you see those field points, here's areas of infrastructure that is managed by OSG. Whereas an empty square is like managed by the site, but there's a high level of support by OSG. But right off the bat here, you see JLab experiments need to have access and need to be integrated with a bunch of different institutional points, from University of Wisconsin-Madison, where some of the infrastructure is working, UCSD, UChicago, BNL, UConn, just to make a collaboration basically work to provide the end-to-end data products for their science mission. So the moment that I click on this animation, you can see that just because I'm talking to a site does not mean that I have a very well, it means that I have a well of understanding, but there is a complex way how information needs to be integrated and propagated through the systems to be able to get to the end result. So if I'm talking to class 12, I'm going through this path here for all the communication of the different processes. Class GlueX changes a little bit the pathway, EIC more, and so on. The takeaway from this animation is that a single collaboration may require an engagement to multiple facilities. And a single facility requires engagement with multiple collaborations. So it's a challenge that we have to overcome in order to be efficient in facilitating solutions to the end-to-end data projects. So some lessons learned. We need to basically identify common problems that exist. And because if we solve a particular problem for a collaboration, that means that we have a solution that can be applied potentially to other collaborations. So we always need to identify the cascade of best practices. How, if we solve a problem for one, can we apply the lessons to another? And the large collaborations, let's say Atlas and CMF, basically pave the way for this. We are not going to rediscover the wheel on the technologies they actually put together, like Rusio, XRD, HT Condor-based distributed processing frameworks, but we're going to adapt them and make them useful for the other collaborations that need them. And so the partnerships between collaboration and OSG facilities will help us basically provide some feedback and input to better inform future projects. An example here is that collaborations could emerge organically through the scope of the future support and the planning of a facility. And also a collaboration kind of evolves. I will give you the example of the South Pole Telescope that is going to transition, hopefully, to the CMBS4 collaboration, which is going to be a much larger project and with similar science missions, but definitely more in depth And how do we basically identify the needs from the lessons learned from SPT3G and apply them on the future collaboration? That is important to track, keep, take notes and, take the lessons and apply them forward.
Pascal, 1 minute.
Yep. Here's an example of the resource utilization for the collaborations here. And I basically mashed together everything that is not just the OSG specifically supported, but also the ones that are out of Fermilab. These are the mid-sized collaborations that I mentioned, plus the 2 large ones. And they account for 270 million core hours for this past year. And it's a mix of open science pool and collaboration-specific resources. The thing that the takeaway here is that we have this opportunity a lot of the times to identify early on how to transition a small group of institutions working together to the kind of like collaborations that we identify, in our pool of resources here that can be best supported with our established methods of support here. And it's a work in progress. We don't have a good understanding of how this transition happens, but we're actively working to identify triggers in the metrics to start treating a collection of institutions as a collaboration and basically approach them in a different way or a slightly different way in the way that we onboard them and support them on OSG. Last slide, or the last before slide, none of these things has mentioned anything about storage so far. And the storage is a whole different beast that we need to tackle. And right now, for example, for collaboration support, we routinely interface with about 25 petabytes of stored data across a dozen institutions with different technologies. And that is a challenge on its own. A challenge that we are trying hard to meet and understand better how it's the implications for the future, but a lot of time and effort is actually spent on data management for these collaborations. Last slide, summary and conclusion. So OSG continues to advance all open science. We have the practice of distributed high-throughput computing. We support many different science domains, large data, compute-intensive workflows. And we advocate strongly for the open science pool as a strategy to democratize access to the DHCC environment. And the particular topic today in my presentation is to tell you that collaborations are an important component in this ecosystem. And we are hoping to continue to support them in the future in how they grow and how they meet their scientific goals. Thank you so much for the time today.
Thank you, Pascal.